So for problem number 1, the first thing I'm going to do is graph 2 to the x, which looks like this. It intersects at 0, 1, and then 2 to the negative x is a reflection over the y-axis, so it's going to be on the opposite side. And then we have negative 2 to the x, and then negative 2 to the negative x. So 2 to the negative x, like I said, was reflected over the y-axis. And then negative 2 to the x would be 2 to the x reflected over the x-axis. And then negative 2 to the negative x is both, so reflected over both x and y. So for number 2, the first step is to solve for x. So we're going to take e to the 3 minus 2x equals 4. We're going to turn that into ln. E to the 3 minus 2x equals ln 4. Ln e cancels, so we get 3 minus 2x equals ln 4, and then just solve algebraically for x. So just subtract 3, and then divide by negative 1, and then divide by that 2. So we get x is 3 minus ln 4 over 2, which is equal to about 0.8. So the next step is to graph e to the 3 minus 2x, but you can't do that yet. So you have to take out the negative 2 and make it e to the negative 2 times x minus 3 over 2 in order to be able to graph this first line. So the first line is going to be graphed at 3 over 2 comma 1, and then the second line is y equals 4, which is a horizontal line at 4. And the point where both of those lines intersect is at 0.8, which is the same answer that we got when we solved algebraically, so we know that that's the answer. So for number 3, we want to find the inverse, and in order to do that, you want to swap the x and y. So you're going to start with y equals e to the x plus 4 plus 1, and swap x and y, so x equals e to the y plus 4 plus 1. And then solve that. So you're going to take ln of both sides, and then ln of e cancels. So you're left with ln x minus 1 equals y plus 4, and then move the 4 over, and we get y equals ln x minus 1 minus 4. So that would be the inverse of the original. So first I'm going to graph the line y equals x, and then I'm going to graph y equals e to the x plus 4 plus 1. So we're going to graph that at negative 4, 1, and then we're going to graph the inverse, y equals ln x minus 1 minus 4. So that's going to be at 2, negative 4, because we went right 1, down 4. So these two are inverses of each other because the x and the y are switched, and they're reflected over that line y equals x. So for problem number 4, we're given negative 3 times ln x minus 2, so the domain for that is going to be 2 to infinity. The vertical asymptote is at x equals 2, and then the x-intercept is at 3, 0, and there is no y-intercept because of that vertical asymptote. So then I'm going to graph the parent function y equals ln x, and then so that is transformed in a few ways. So the first one is going to be by that negative in the front, which signifies a reflection over the x-axis, and then the 3 is going to be a vertical stretch by a factor of 3, and then the negative 2 is going to be a shift right 2. So if you put that all together on the graph, that would look like this, with an intersection at 3, 0 for the x-intercept.